Physical property of the aquifer. The first property is the porosity. The definition of porosity is equal to the volume of void, V sub V, volume of void, divided by the total volume of soil. Okay, so V sub V is comes from the total volume of soil, subtract the volume of solid soil. Okay, that is the porosity. This table shows the porosity is a function of the soil texture. Okay, you see that sand is about 0.395, but clay is about 0.48. It looks like the sand should have the porosity more than the sand clay, but this clay is a bit higher compared to the sand because the small particle of clay, but still have some void between the particle. This is a soil and rocks cross section. You can see the void between the particle. The water can store in the void. Okay, but if this grain side is different side of the grain stay together, so the void is very small. Yeah, even in the rocks, if there's a crack in the rocks, so it means the water can stay in these cracks as well. The second property is the capillary retention is from the. You can imagine that if this is the water and we put some tube from the basic hydraulic. A small tube put in the water, so we expect that the water in the tube will come up to this level. Okay, so this is because of the capillary retention that the water can move against gravity from the water surface. So this we call capillary fringe. The other property is a specific storage. Okay, the storage property of this comes from the volume. The V sub W is the volume of the groundwater taken from aquifer divided by the total volume of the aquifer and divided by the decrease of pressure head. Okay. So we expect the unit of the specific storage is 1 over L. And next is we call the storage coefficient or storativity. The difference from the specific storage is divided by the area, not the volume, okay, because of the depth of the flow is not constant. So A sub A is mean areas of the aquifer. For the confined aquifer, we expect that for storage coefficient is very small, and for the unconfined is a bit larger. So we expect that unconfined aquifer contribute more water than the confined aquifer compared with the same area and same pressure drop. And we can write the equation from the connection between the storage between the specific storage and storage coefficient based on this equation. B is the thickness of the aquifer. And the next property we call the specific yield. It's the volume of water can release from unconfined aquifer per unit per volume of the aquifer. This is released by gravity. So we can see that for normal sand, coarse sand is about 28%. So mean is if the moisture content is above this, the water will drain from the soil. If it's less than this, is okay, stay in the soil. Okay. Since say for clay it's very small, 3% for the specific yield. Okay, and the last property is the transmissivity. Is from the hydraulic conductivity. Later on we're going to discuss about this. What is the hydraulic conductivity, where it comes from, and now B is mean thickness of aquifer. So we can estimate the transmissivity. This show the hydraulic conductivity is depend on the soil texture. You can see that for the coarse sand is about 45 meter unit of the hydroconductivity is like the velocity for 45 meter per day. But for clay is very small. This table shows the range of the hydraulic conductivity. Okay, for the clean sand, the range is from this about this range to this range. So it's about for grain sand, it's about 10 power 4 to more than 1. So it's a wide range of the hydraulic conductivity for each soil texture.